Good morning, welcome back. Let's finish with arrays and then we can move to structs. This is the closest thing that we're going to have to classes, but this is C, and well, classes is object oriented, it's going to be C++ and Java. So we're going to review struct today. The closest thing to classes that we can have in C, the next step after arrays. But first, we need to finish with arrays, and we need to talk about 2D, 3D, and so on arrays. So let's start. Before we start, quick announcements. We're going to have a new quiz, the last quiz about C, the full quiz about everything in C. And assignment three, basically pointers and all the topics related. Both, the plan is for them to open October 1st, because what we're going to talk today, you need it to complete the quiz and to complete the assignment. So they open after our class Tuesday, and they are due in 1 week. So October the 8th is due date for the quiz and the assignment. The plan for October 8th is also to maybe do a small review. The goal is 1 week later to have the first exam, the first midterm. Probably what is going to happen, the lecture before October 15, is that we're going to start with C++, but C++ is not going to be included in your exam. So basically your exam, everything that we have reviewed, concept, theory, Java, that you already know as a prerequisite, and C. And regarding C, well, all the topics that we have covered. Remember, the exam is comprehensive. So you have 15 days to start reviewing things, review the lectures, review the slides, and we're going to run a review. In particular, my goal is to have Jacob running the review. So if you have a particular topic that you would like to be covered during the review, please be in contact with him, share ideas. The idea is to have one full session, 1 hour and 15 minutes for the review, and 1 week before the exam, so you can have time to review the review. Good? Okay, so moving forward. Let's talk about 2D arrays. 2D arrays. Something that you should know right now, something that we have mentioned several times, is this idea of the 2D array is just an abstraction. Because really what's happening in programming, what is happening in your computer, is that an array is just a pointer pointing to your data. And your data is consecutive data. That is an array, period. There is no other thing like that. You are never going to have a cube or a table or something like that. However, you can create something similar to those kind of pictures. For instance, you can have this array, and if you make every one of the elements a pointer, well, they can be pointing to an array. And usually this is what you call a 2D array. In order to facilitate things, when your instructor in CSE240 explained to you 2D arrays, well, they focus on this, and they mention that like a table, you know, because the columns and rows, but that do not exist. Really, when you have this as an X, and you are doing something like X, 1 and 1, what you are doing is the first index is the index in one of the arrays, and the other is the index for the other array. And that gives you the idea of the position 1 and 1, the column 1, row 1. But really, you are moving in a group of one-dimensional arrays. Obviously, in order to achieve this, well, this one here should be maybe a value. The values are integers. If the values are integers, every single one of these elements here is a pointer to an integer. So you can have this arrow, right? So basically what you have is an array of pointers. Now, that array of pointers, this one here, well, should have a pointer to the first element. The name of the array is really a pointer to the first element of the array of pointers. So it's a pointer to pointer. Did you notice the values, integers? This one is an array of pointers to integers. And the name, the one that you know as the name of the array, is really a pointer to pointer, to asterisk. And you can create this in two different ways. You can create something like that doing, I want an array X, and I want that array to have 3 rows, and I want this array to have 4 columns. That is basically what I have here. And if you do this instruction, that instruction is creating one pointer to pointer that is going to be called X, is creating one array with 4 elements, the 4 columns that are pointers to pointers, pointer to pointer in asterisk. And then for each of these is creating 3 integers. Now, I am drawing this, trying to have this nice table, but really in the memory of your computer, what you have is, this is the memory, probably this is X, and this X is storing the address of something that is here. And probably this first element have the address of something that is here. And the second one have the address of something that is here. Because you have the address, you are supposed to be pointing to those things. But there is not such a table or a 2D array as we imagine. Makes sense? Now, if you do this, use that instruction. That instruction is going to create all of this in the heap or in the stack. Anyway, heap or stack. This instruction to the array, where is going to be my array? Good, thank you, in the stack. One of the advantages of C and C++ is that you can decide if you want your arrays, your objects in the heap or in the stack. It's your decision. Moreover, it's very, very easy, just like this, and you are going to notice the same similarity with objects. It's very, very easy to create arrays or objects with a short instruction, a short line. You do not need the long lines and several instructions that you need in Java with the news and other things. You do not need it. But these arrays or the objects that you create like this, they are going to be in the stack. In Java, you need all those instructions because arrays and objects always go to the heap. Here, if you follow the easy way, they are going to be in the stack. And as we talked before, you do not want your arrays, moreover this one, too big. You don't want this in your stack because your stack is small. So what you want to do is to send all of these one-dimensional arrays outside to the heap. And if you want to send this to the heap, well, instead of following this instruction, we need to use our friend malloc. And if we're going to use malloc, we need to remember that it's important to use also free. So in the previous lecture, I showed you how to create one-dimensional arrays or any variable in the heap. The only thing that I need to do today to close is how to use malloc to create arrays that are multidimensional. Very good question. What happened if I do a free for this guy? And if I only do the free for this guy, well, it's pointing to the first element here. Know that this is an array because the malloc is going to tell you the size. The only thing that the free is going to clean is all these elements, only these ones. What happened with those elements below? They become garbage. What do we need to do? Well, we need to clean this one, and then we need to clean this one, and then this one, and this one, and at the end, we clean this one. We are responsible for cleaning row by row, one-dimensional array by one-dimensional array. Freedom, responsibility, makes sense. When you use free, the only thing that you free is one line of elements, one-dimensional arrays. Why? Because you know the address of the beginning and you know how many elements you ask for in the parameter of the malloc. So the only thing that you can clean is that line from the beginning to the number of elements that you requested. Here, 1, 2, 3, 4, 5, freeze. And moreover, in order to create something like this, you need 5 mallocs, not only one. You cannot create a 2D array with only one malloc. I am going to show you the code. This is what you need, right? Now, notice, I can put this at the top or this like this. It uses a picture. And I am using both because you are going to read a book. And for some authors, it's like this. For others, it's like this. Remember, it's just a picture. None of them is true. The only thing that is true is what you have is a collection of one-dimensional arrays. But in the memory, they are never a table. Obviously, they are not a cube in a 3D array. They are just a bunch of lines connected with pointers. That's it. Now, this picture. You remember the picture. Line, 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 line. The green one, gray, and yellow. What do you think about this code? What is happening there? For your exam, something that hopefully by now is clear and you can remember is the libraries, functions that I am using from stdio, printf, scanf, functions that I am using from stdlib, malloc, and free. 2 libraries, 4 functions that I am using. My main, returning an integer, is fine. I am returning an integer. 0 to indicate that there are no errors in the program. I am assuming that if my program runs this last line, nothing happened bad. So far, so good. My array, well, my array is going to start here. Notice, I want a 2D array. A 2D array is a pointer to pointer. A 2D array is this array asterisk asterisk. That is going to be one variable. That one variable is going to store the address of a pointer. The casting used to give you the idea of what is being created. Malloc. How many elements do you want? Well, remember that you need to tell me the number of bytes that you want. The number of bytes. Usually what you do is, you know what? I want 3 elements. 3 elements, I want to create this table with 3 rows, 3 columns. 3 elements, but the 3 elements that I want are these 3 pointers to the arrays that are going to have the values. So I want 3 times the size of int asterisk. It's not the size of int, because what I want is not 3 integers. I want 3 int asterisk. Remember? Pointer to pointer. I want 3 pointers to int. So I can put there the number of bytes, but I really do not know how many bytes is a pointer to integer. Well, I know 4 bytes, but depending on the computer, that can change. It's safe to ask for the size of the pointer 3 times. And that is going to be the size of the first array, the one that I connect with the name of the 2D array. Well, wait. This is not a keyword. Array is the name of my array, and that one could be X, Y, or Z. There is no keyword array here. Good? Yeah, you can put the asterisk between the type and the name, but it doesn't matter if you put them immediately after the type, like asterisk asterisk close to int, like int asterisk asterisk, white space, and then the name, or the opposite, the type, white space, asterisk asterisk, and then the name. It doesn't matter to which part you put them together, but they should be together with the type or with the name between that. Good question. It is the same size of int and size of int asterisk. So usually what we do is ask for the size to the system instead of writing here a particular number. It's just programming safe. I am asking you computer what is the size, and you computer are the ones that are telling me that is 4, even though I can assume that is 4 right now. Good? Important thing, the first time I am asking for the size of the pointer, not for the size of the data type. And this malloc is the one that is going to give me this array. And can you notice what happened in the next 3 lines? I am using different notations in blue. Hopefully you remember the previous lecture. This is exactly the same than this or this. 0, 1, and 2. But my point is you can use array square bracket 0, array square bracket 1, array square bracket 2, if you want to follow the array notation, or you can use the pointer notation, asterisk array plus a particular number, 0, 1, or 2. Moreover, you can use only asterisk array, and asterisk array is exactly the same of this one. Adding 0 do not modify anything, but usually you put the plus 0 for the people to remember that that one represents the index 0 in the array, the first element. use notation. For the computer, it's going to be the same. And these three guys, the three elements in the array that I just create, they are pointers. Because they are pointers, they can store the address of an integer. The address of an integer that you can get with malloc. But if they are going to store the address of an integer, these mallocs are going to be 3, but now size of integer. Because what I want is this one, 3 integers. This one, 3 integers. This one, 3 integers. And what you have is your bidimensional array of integers, this, but notice the structure that you have. The name of the array is not connected with the values, but with another array, which is the one connected with your columns or rows of values. Ask the computer and multiply the size for how many elements you want. I mean, this is very common of things that you're going to find in a book, software online, your own programs. It is safe to ask for the size, even though you think that it's obvious, it's going to be 4. In my computer, it's always 8. Ask for the size. In your case, you are running your program online, you are running your program in your super laptop, but when you submit, the TA is going to be grading your program, and maybe the laptop of the TA, my laptop, is not as powerful or as top of the line as yours, or the opposite, and your program maybe is going to not work as you expect, right? So ask for the sizes always. And you can print the sizes. Remember, print F, size of, whatever, and you can discover what is the size of the pointers and the data types in your system. Anyway, with this, one malloc for the 2D array and one malloc for each of your columns or rows, whatever you want. And then you can use your array like this. You can use the notation of the two-dimensional arrays. You can use this notation of square bracket, even though here you never use square brackets to create the array. Well, I use square brackets here, right? But I can change that for asterisk. The notation of the asterisk or the notation of the square brackets is just notation. You can use any of them. Moreover, this is the easy way. This is the way that you are used to work with arrays. But really, this is what is happening. And I want to be sure that you understand what is happening in the red line. What is that crazy thing? Array plus 1, the asterisk, plus 2, the asterisk. I need you to agree that this array, square bracket 1, square bracket 2, is the equivalent to this thing. Why? Let's check. Array. Array is this guy. In particular, array is whatever number is here. And the first thing that I am doing is, well, whatever number you have here, plus 1, I am going to add 1 to the address that I have in that box. Okay. And then I am going to apply the asterisk. And when you apply the asterisk to this address plus 1, you remember this address is the address of the first element. Plus 1 is not really plus 1, is plus 1 times the size of the type. So in this case, it's plus 4, maybe. Whatever. We don't care, because at the end is the address of the second element, right? It's like plus 1, and I am in the second element because the computer is going to do the arithmetic of pointers by itself. So I am here. This is asterisk x plus 1. And what I have here is another address, plus 2. What I want now is to add 2 to the address that I have in this box. So in this box, I have the address of the first element of this one-dimensional array. And when I add 2, again, it's going to be plus 2 times the size of the data type. And then I am using for the second time the asterisk. Whatever address is here, plus 2 is going to give me the third element in this one-dimensional array. And what I am doing is, in that place, I want to put the number 3. The number 3 is going to be here. What I did is to follow this arrow and then to follow this arrow, and at the end, I get access to this space. That again, that space is just jumping here, and then from here jumping here, and from here maybe jumping there. It's not a table, but if you use this instruction, it's going to be translated to this, and you as a programmer, you are going to think that you are working with this nice table and you are doing something with the row and column 1 and 2. Even though that is not exactly the case, you are really jumping into the memory. Anyway, 2D arrays. 1 malloc for the array, 3 mallocs or several mallocs for each of the columns or rows. And you can put values. You can print in this way or print in this way. Work with the array. What about the freeze? I put the comment there. My main is going to finish. What should I do with the freeze? Is enough one free, or maybe I need more than one free? What do you think? Could it be free array position 0, free array position 1, free array position 2, and finally free array? Clean the columns, clean the array that was connecting the columns. Well, the opposite. You need the free for, you need to free the pointers to values. Yes, the int asterisk, that is correct. And the last one is going to be the free for the pointer to pointer. Yes. So if you have the values, first the free, the pointers that are pointing to the values. So you clean those spaces, and then yes, the free for the pointer to pointers to clean the array to pointers. Now, what I show you is this idea of malloc with an array of 3. But what happens if I want an array in which, for instance, and this is something that you're going to need for the homework, and probably you're going to review for the exam. What happens if I want to ask the user, how many columns do you want? And how many rows do you want? I want to create an array, and I want to ask the user for the size of the array. You can ask for the numbers using scanf, right? Anyway, I am going to use these numbers. I want this array with my 3 rows and my 4 columns. These numbers. But obviously, if I change these numbers, if I put a bigger number or a smaller number, whatever, I want this program to continue working. Maybe I want to pass these numbers in the parameter of a method for your homework. A method that receives the values for X and Y as some parameters, and X and Y are the number of columns and the numbers of rows in a 2D array. Well, I have the numbers. Could you agree with me that something that we can do is using these variables? How many rows do you want? How many columns do you want? Something that you can do is, for instance, line number 6, you need one malloc, that is the malloc for the pointer to pointer. So in this case, this guy here is R, the name of the array. Now it's not array, R. And the first thing that I do is, for that pointer to pointer, I am going to create an array of pointers. An array of pointers, this one. Each of the gray boxes is going to be a pointer to values. And in this case, well, the number of rows, 3. I want 3 elements here. Now, for each of these, I need to do another malloc. In general, you need a malloc for every arrow that you draw. Instead of doing what I did before with my 3 instructions, something that you learn is, well, we can use a loop. And that loop could be 0 to something, like the number of rows that you want or the number of columns. And probably here, the number of columns. And you're going to do another malloc for, for each row. 3 rows, 3 mallocs, but instead of the instruction, I put the instructions in a for loop. And well, size of integers, no pointers. Now I want the integers, and I want 4. 4, see. 4 loops to create the 2-dimensional array. Yes, this is a good opportunity for you to use a constant. Yeah, those 3 and 4 can be constants. Remember, this example you can split into different versions. Version number 1, you can make R and C constants if you know that your program is going always to use these 3 and 4, like the size of the array. For a particular problem, maybe you need a constant number of elements. The other thing that you can do is replace my line 5, and instead of giving values 3 and 4 to R, you can change here something like, well, scanf, and I am going to ask for a number to the user, and I am going to store that number in R. And remember that you need the ampersand. So you can do this and ask for the value of R, and whatever the user select, like 10, 9, 8, 11, that is going to be the number of rows in your array, instead of the 3 that I am using right now, mandatory, just for the picture. Good? Okay, so with this here, you have your array. Whatever we do below, like this, I am going to put values. And if you notice, just because it's easy, I am following with this representation here, square bracket, because it's an easy notation. I do not want to use the other one. However, if I want to make my program more interesting, this line here, hopefully you agree, well, that one is something like asterisk, asterisk R plus I plus J, more or less. Every square bracket is an asterisk and a plus something. So if I have 2 square brackets, that means that I need 2 asterisks and 2 plus something. Obviously, reading this is easier and allow me to think about this fancy table instead of doing this, but they are the same. Put values in the array, print the values in the array. I am practically working with the array. And at the end, here, I need to do the freeze. What do you do for the freeze? Maybe, use maybe. Can we use a for loop? Can we put inside of the for loop some kind of free instruction? And now, instead of another instruction before, a free at the end, and in particular, this free here can be for the 2 asterisk, and this free here can be for the 1 asterisk. No, never. Answering the question in the chat, you can use this one or this one. If the question in the exam is to write a program, is your choice. However, there are going to be questions in which I am going to ask you to translate from one to the other. Or there are going to be source code that I give you, and I am going to ask you what this code is doing, and I am going to use one or the other. So my request is you should understand both, but when you are free to use any of them, you can probably select this one, that is the easy one. Different sizes of subarrays? I'm not sure about the question. Well, going back to the freeze. Can you agree to something like this? Can you complete this program with the freeze doing something like this? You need this for your homework. So my recommendation, this source code and the previous one, play with them. Moreover, can you imagine what to do in a 3D array? Can you imagine how many mallocs do you need if I ask you to do a 3D array that basically have 2 columns, 2 rows, and something like this? How many mallocs to do something like this? Moreover, how many pointers to pointer to pointer? How many pointers to pointer? And how many single pointers? And how many values? The easy one. How many variables that are going to be pointers to pointer to pointer, 3 asterisks, do we need for something like this, a 3D array? Easy, right? 1, the main one. How many pointers to pointer? That is going to be one of the arrays, right? Can you agree with me that this one is going to be pointing to something? And that one is going to be pointing to something. And these 4 are going to be pointing to something. and basically the yellow things are really the ones that are going to have the values. So eight values, 4 and 4, that is my cube. But those 4 values are really 4 unidimensional arrays connected with other unidimensional arrays connected with other unidimensional arrays. This one is asterisk, asterisk, asterisk. Use this one. These two are asterisk, asterisk. This is asterisk, 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 because are pointing to values. I have one that is pointer to pointer to pointer. I have 2 elements that are pointers to pointer. And I have 4 elements that are use pointers to arrays of values. And in total, I have 8 values because I have 4 arrays and each array have 2 values. This is the picture. Now, my question for you in the exam is, can you give me the source code in order to create this? Moreover, can you give me the source code to create the array? And well, now that we are there, can you put the number 1 here with whatever instruction you need to use? Or I can give you the mallocs for this. I can create the array for you, but then I can ask you, can you give me the freeze that we need? And just to be sure, a free, whatever is the name of this guy, use a. The answer is not as easy. Because if you do only this, what you're going to free is only these 2. And everything else is going to be garbage. The solution for the freeze, a little bit more complex, as well as the mallocs. It's not only one malloc. You need 1 free per malloc. How many mallocs do we have here? The same number of frees. Remember the example? Parentheses. Malloc, free. Malloc, free. 2 mallocs, 2 frees. A 4 with mallocs. My recommendation, the same for loop, but now with frees. Yep, something like that. Again, the recommendation, use the for loops, but you can do line by line. 1 malloc here, obviously, the mallocs here, I have 3, and for here, 7 mallocs, good. And for the free, the expectation is 7 frees. Well, maybe 1 inside of a for loop of 7. Oh, that is not possible because they are different types. A for loop with 4, another for loop with 2, and 1 alone, or 7 alone if you want. But at the end, when you do the math, it should be 7 executions of free, 7 executions of malloc for this simple 3D array. I am not going to use 3D arrays in your exam. Worst case scenario, 2D arrays. So please review this one and review this one. Be sure that you understand this. Moreover, your homework, the one that opened October the 1st, include 2D arrays. So you're going to have opportunity to apply this in a particular program. Good? That's it. Arrays, pointers. Moving forward. Next step in 20 minutes. Yes, very good question. the thing that you have in the chat. One thing that you can do in C, and you can do the same in Java. This thing that I am showing you with the mallocs is exactly the same thing that you do in Java with the 2D arrays. So it should not be new. But now that you know that a 2D array can be created with more than one malloc, the question is, well, I can have this 2D array pointing to these 3 pointers. But then what happens if I do the malloc for this one, size 1, and the malloc for this one, size 2, and the malloc for this one, size 3? Can we do that? Because that one is a 2D array, but this is not a table. It's like one element in the first column, 2 elements in the second, 3 elements in the next one. Can we do that? Yes. Why not? I mean, that one in the example, I am using here always the same constant C. What happened in this program if instead of using C here, I put I? How many elements in the first array? 0. The second one, 1. The next one, 2. Nothing happened. You can do it. It is not true that the 2D arrays are tables. You can create these crazy shapes because 2D arrays do not exist. It's just a collection of one-dimensional arrays. So the answer for the question in the chat, yes, you can have different sizes of mallocs. You can do it. The computer is going to tell you good is null. So yeah, if you put the I there and the first value is 0, it's going to be okay. The computer, one good news with C is the computer is not going to complain whether or not you want the first array to be null. I mean, the first column to have no elements. Maybe it's the case, maybe not. Up to you. I can assume that if you're doing a matrix and it's a triangular one, you want the first column empty. It's valid. Good. Okay, play with these guys. Anyway, moving forward, we just finished with the most complicated topic maybe in the full semester: pointers, strings, and arrays. If you get this, all the things that we reviewed in the previous 2 weeks, that is the best thing. It's going to be in your final exam, it's going to be in your midterm exam, the homeworks, several quizzes. I could say the most important topic for you to review. Anyway, moving forward, we are done with arrays, pointers. What we want is to move forward to classes. We're going to be reviewing C++ soon. So between C++ and the arrays, we need to review some things in the middle. 2 important things. Number 1, a fancy thing that you can do in C and C++ also is you can change the name of your data types. There is a keyword, typedef. Typedef allows you to give a name, whatever name you want, to a data type that exists already. This is important, guys. Question in your exam: what is the goal of typedef? And a lot of time you make the mistake to tell me typedef allow me to define a new data type. And that is not true. You cannot define a new data type with this. The only way that you can define a new data type is with the class. Remember, typedef allow you to give a name, a new name, to a data type that already exists. For instance, you know what? I really miss the Boolean data type. I need a Boolean data type. I want to create Boolean variables. Moreover, I think the Boolean data type should have more O's. I want this Boolean, and moreover, I want one of them to be uppercase. I like that. Okay, you can use that name, the red one, for another data type. For instance, you can use that red name for the int. And then in your programs, you can create variables that are Boolean. For the computer, this is, it's like you want to use a different name, good for you. But for the computer, your name is equal to your definition. You know what? For some reason in my program, I want to use this name flag type just because it's something important in my program. It's kind of a letter. Okay, you can use that name for char, and then you can create variables. And for the computer is char y equal a. Again, you can put a name to any data type that already exists. The data type already exists. The only thing that you are creating is defining a new name for that with the typedef. Type definition, a new name for a type that you already have. Remember that type definition is not creating a new type. It's just a new name. And you can do crazy things. If I give you this program, the one in the box, in your exam, are we clear about what is happening? Now I have the data type letter. I do not like char, so letter y equal a. I can do that because I define letter as char. I can also create a variable cat w equal 1. The data type is cat. Not really, it's int, but you define these names for the types. The values do not change. Use the name of the data type. Okay, now this one is something that you can combine with another thing that I am sure you remember from Java. Do you remember the enums in Java? Maybe you reviewed those. But the enums allow you to define particular values for a variable. For instance, with the enum, you can define as values true and false. Remember? The enum is creating this data type in which true and false are values. It's not true and false. Enum is creating this false is 0, true is 1, or whatever names you put inside of the square bracket or the curly brackets. They are numbers, but enum help you to give names to those numbers. Now, if you put together enum that you know from Java, it's working in C, with this typedef, I can create this typedef Boolean, and I can do something like this. My variable is Boolean. I give a new name. In this case, this is the same that int Why int? Because I am using enum. Every single time that you use enum is an integer variable, remember? And this int a is equal to false. False is the first element in the enum, the first element in an enum with no other specification is going to be 0. This line here with enum and typedef is creating a variable a equals 0. However, with the typedef, instead of using int, you can use this boolean. And with the enum, instead of using 0, you can use false because it's a collection of new values that you are defining with enum. Yes, the basic idea of typedef and enum, the only reason for this to exist is for your code to be easy to understand or more difficult to understand depending on what you do, but it's only about readability. When you click compile, this line is going to become that one. For the computer, this is just a decoration of this instruction. That's it. The performance is not going to change. The results are not going to change. The only thing is you are reading this. Your reader is reading this. But when you click compile, this is your source code. In the code that is going to be translated to machine language, is going to be this one, not the other. Good? Readability. Yes, all of that. Good. Similar idea. I can do something like this, hopefully in your exam. I want a variable days. Okay, days. It's an enum. It's an integer. The variable is x. And I have x equals Monday. Okay. 1. And I have another y, also days. Friday. Five. And then I can print this one, that is x plus y. What is going to be printed there? Can I do x plus y equal today? Because x plus y was Monday plus Friday. Well, but they are numbers, so it's going to be 1 plus 5. So the result is going to be 6, right? Yes, you can do it. That is my question for you. Remember the type? 6 or Saturday? Percentage D, right? Yeah. Well, the only order for the enum is the first element is 0. Whatever you put there, the second is 1, 2, and so on. I mean, the order in which you put the labels, they are going to take the values 0 and they are going to increment. So that's it. Again, the value here is going to be the 6. So you can even do a multiplication of Friday times 5, and it's going to be a value, whatever, that is not here. It's going to be a number. Remember, the variables are numbers. The only reason because you use these days is because it's fancy when you do the declaration. And regarding the values, the only reason is because you can use this label instead of the value when you do an equal. But when you start doing operations, they are integers. So you can do multiplication, division, model, whatever you want. Even you can compare something like this. And what you are doing is with the numbers. I mean, this. And if you put the names in the opposite order, again, you are comparing the numbers. It's not going to be related really with the days or something. is just labels, and you put those labels to particular values, and you put those labels to particular data types. So typedef to put a label, another name to a data type, and enum is basically to put labels, names to integer values starting from 0. Good. Yeah, it's going to print the value. It's going to give you an error because fake they do not exist. It's not the name of a variable, it's not the name of a label. So the compiler is going to tell you, I do not know what is that. In order to print the names, you need a switch. You can use a switch case. And in the switch case, you can use, for instance, here, I have this enum with these names. You can use a switch, and in the switch, you can use those names. And then you can print whatever you want. But you are not printing the labels in the enum directly. If you're planning to print the names, the best solution is put those names in an array. The array is an array of strings, and then you can print the element 0 in the array of strings, and that element 0 is the name. That is a better solution if you're planning to print an array of strings instead of the enum. The enum is basically, I do not want to print those names, but those names are names for some constants that I use in my program, and instead of using the number, I want to use those names. For instance, when you're programming something that have different states, in this case, the traffic light, instead of using randomly, okay, state 0, state 1, and state 2, that do not mean anything, you can use these names, red, amber, green, and it's basically red is 0, this is 1, and this is 2. Increase the readability of your program. But this is not something that you're going to be able to print. If you want to print it, again, an array of strings. That is your best choice. Or the easy one, a switch case, and depending on the name, the value for the variable x equal amber, then you print something. Good. Okay, so typedef, enum, that is easy one. Structs, and I have 2 minutes for the introduction. Easy. Class, curly bracket, closing curly bracket. What can you have inside of a class in Java? 2 things, right? What? Variables and methods. Good. Classes, object-oriented. They do not exist in C. They exist in C++. They exist in Java. In C, the closest thing to a class is something called a struct. By the way, struct, just like class is a keyword, struct is a keyword. And just like when you create a class, you put here the name of the class, class n curly brackets. When you create a struct, you give the struct a name, open, closing. One difference, inside of a struct, you can have variables, the same as the classes. You cannot have methods. When you put methods inside of a struct, that is a class. And just remember, C is from the 70s. In the 70s, people created structs. People put variables inside of this struct thing. In some point, someone had the idea of adding methods inside of the structs. And these structs with methods, they decide to change the name. And the name for the struct with methods, classes. And that is the 80s. Structs is the grandparent of your classes. A struct is like a class without methods, or a struct is a collection of variables. That is an example of a struct. The struct person. By the way, for the structs, you do not use uppercases for the names. That is something that is going to happen with the classes. I mean, you can do it, but it's not the rule. My struct person. And as you can imagine, I have two variables there, two attributes. The name, an array of 30 characters, and an ID, an integer, a collection of variables, like a class, but without methods, without constructors, without setters, getters, nothing. Use the variables. And the variables like public in a class, so I can access the variables always. There is no public, private, or protected yet. Those things are going to come with the classes. But if you are wondering, they are public, private, or protected, by default, they are public. The original idea was everything is public. Later, we get concerned about making things private. A struct, variables, public, attributes. And something that you are going to notice, and we're going to talk more about this in the next lecture, is our friend, the dot. Do you remember the name of the class, dot, the name of the variable, or the name of the class, dot, the name of the method, or the name of the object, whatever, with the dot? Here is our friend, the dot back. Well, in fact, the dot was there from the 70s. In the 80s, the dot became part of the classes. But with the structs, we also have the dots. Take a look at this program. By the way, I can put the struct in the same file that I have the main. It's not a class yet, right? My main, my struct. Not yet. We're going to work on that. So I am going to stop here because the time. Take a look at this example, review typedef, enum, and more important, review the 2D arrays. 2D arrays is in your homework open October 1st after the lecture. Good? Okay, guys, see you next lecture. Thank you.